This is the final presentation for the Six Sigma project of Team 3. The name of the project is Regaining Control of the Drilling Process in the Cascade Creek Field in Colorado. Team members include Carlos Amaya, Jose Luna, Cipra Malik, Fabiana Manso, and Cheng Yang. The sponsor company is one of the top 5 exploration and production companies in the US, which is a leader in applying advanced technology to boost production and access hard-to-reach reserves. The company is committed to respecting the environment, maintaining safety, and upholding high standards of social responsibilities throughout the company's worldwide operation. The problem that is being addressed by this project is the loss of drilling fluid used to drill wells in the Cascade Creek field in Colorado. The picture depicts the location of the wells that are being drilled.
The general drilling process that is used in the Cascade Creek field is described according to the following steps. First, the conductor case is set at a depth of approximately 100 feet. Then the drilling process continues and the surface casing is also cased and cemented until the depth of approximately 2,700 feet. The surface casing is pressured at 1,500 psi for 30 minutes to test the capacity of the casing to isolate the wellbore from the rock. Continuing the drilling process, in step 4, the production casing is reached at a depth of 9,000 feet. The casing is equally set and cemented. Step 5 in the process is the testing for the production casing, which is done at a pressure of 2,500 psi during 30 minutes. The last step indicates the drilling process is ended. The inputs required for the process include drilling equipment, drilling materials, drilling crew, a company representative, service company representative, and the drilling information. The suppliers are equipment vendors, material vendors, and the exploration and production company. The output of the process is a completed gas well that includes a producing casing cemented to surface, ready for the completions and production department, which is the customer. During the drilling process, the drilling mud is used to lift the rock cuttings to surface and to provide well control. The measurement system flowchart shows how the mud is measured to provide information about fluid loss and fluid influx from the formation to the wellbore. The measurement system is done in 2 main phases by the mud engineer, who reads the heights in the mud pit from the mud level rule. The engineer calculates volumes and takes the pumping rate in stroke per minute from the electronic display on the mud pump and converts units to barrels per hour. The measurements in this phase are done before drilling and when the mud is returned to surface. The another phase involves the fluid loss estimation that is related to the fluid adhered to the cuttings. The measurement system flowchart ends with the drilling fluid report, which contains data of fluid influx and fluid loss.
This histogram shows the fluid loss data collected from the 50 wells drilled in the Cascade Creek field in Colorado from January to December 2010. The histogram indicates that the average fluid loss was about 3,400 barrels with a standard deviation of about 1,500 barrels. The team made the problem and the mission statement as follows. The problem statement is the EMP company has an average 3,400 barrels per well of fluid loss in 50 wells drilled in the Cascade Creek Belt in Colorado from January 2010 to December 2010, resulting in additional drilling operation costs. The mission statement reduced the average fluid loss to less than 2,500 barrels per well drilling in the Cascade Creek Belt in Colorado in the next 6 months by October 2011, resulting in a cost saving of approximately 11,500 per well. The team created a cause and effect diagram in terms of statements to identify the causes.
The team used the cause and effect diagram to identify the potential causes of the fluid loss problem. In a meeting with the personnel from the exploration and production company who are directly involved in the drilling operation, it was concluded that there are 6 major cost categories. The meeting included supervisors, engineers, and field operators who have participated in the drilling campaign in the Cascade field between January to December 2010. A brainstorming exercise with the drilling personnel allowed to identify about 60 potential causes and subcauses. In order to identify the critical causes from the potential causes, the team listed all the potential causes and looked for the causes that appear repeatedly across the major categories. The data was gathered using a check sheet to determine the relative frequency of the different causes. The data showed that the top 3 potential causes with the highest number of occurrence are mud design, the casing depth, and the drilling method. The results of the analysis were discussed with the drilling personnel to confirm that the founding causes had a physical and practical relationship with the fluid loss problem. The engineers confirmed the physical relationship of the mud properties, the casing depth, and the drilling method with the fluid loss of mud into the rock. The team is going to focus on the drilling mud design, which has the highest occurrence among all the potential causes.
The next step is the improvement phase. The team used a prioritization matrix tool, or it also called option criterion matrix, to improve the mod design. Adding components to the mod like air, nitrogen, and another chemicals are the proposed solution to reduce the fluid loss due to mod design. Each proposed solution was evaluated considering the desired characteristics such as safety, low density, easy handling, cost effectiveness, environmental friendly, availability, low reactivity. Through this analysis, the team found that the adding nitrogen to the mud had a maximum score of 41. Therefore, the team concluded that adding nitrogen is the best solution to reduce the fluid loss. Till now, the team has covered define phase, measure phase, analysis phase, and improve phase. Looking forward to more in depth into this project in the near future. Thank you.